Good morning, good afternoon, good evening. Welcome to all of you, wherever you are. Every 2 months, you have the opportunity to address some of your concerns, from the practical issue to its scientific explanations, with experts from all over the world, from academia as well as industry. Each webinar will start with introduction of the field situations through testimonials, videos, interviews, and then two well-known scientists will explain the fundamental basis of those issues, and a roundtable will allow you to give questions to our invitees. It is our second FeedChannel webinar today, and we are pleased to welcome many participants. And I just remind you that you can always put a question on the site during our program today, and they will be addressed to our invitees. Over the last few weeks, lots of communication, publications, webinars concern gut health. I'm sure that you know that. This week is also organized the second International Symposium on Alternative to Antibiotics, entitled Challenges and Solutions in Animal Production. It is organized by ATA, it is organized at OIE headquarters in Paris, and you will have the opportunity to listen to some participants on the FeedChannel.online. But what does gut health mean? Why do we need to get rid of antibiotic growth promoters? How can we efficiently replace those AGPs? How to develop new solutions? What are the issues, criteria when developing alternatives? Lots of questions we need to address. But how to start? Our animals are eating a lot today to support their genetic potential and their tremendous performance. And their digestive tract is thus almost always challenged. Moreover, the indigestible fraction will give substrate for the microbiota in the hindgut, and we focus for many years about feeding our animals on feed digestibility, feed value, and so on. But we should be more concerned maybe by the fact that we are feeding an ecosystem. That's why nutrition ecology might be more relevant. I'm pleased to welcome today Professor Philippe van Immersel as an expert on gut microbial ecosystem. Good morning, Philippe. Which he considers this gut microbial ecosystem as a key mediator of intestinal health in poultry. And Professor Theo Newald, who promotes the importance of gut inflammation to explain the benefits of antibiotics, as well as to develop efficient alternatives. Theo is unfortunately experiencing his own inflammation and a bad virus today, and he will talk from Belgium as far as the technique will work. Both Philippe and Theo will address what do they mean by gut health and how can we develop alternatives to antibiotics. A week ago, we interviewed Dr. Thibanchot from Mixed Science, Avril Group. She explained how AGP ban expected by end of 2017 in Vietnam is an issue and how it is perceived in Vietnam. So let's listen to Dr. Thibanchot for a few minutes. So I'm pleased to welcome today Dr. Thibanchot from Mixed Science, who is sharing her life between France and Vietnam. Could you tell us more about your function within Mixed Science, Dr. Thibanchot?
Well, I am in charge of business and development and innovation within Mixed Science. And by the way, I'm president of Mixed Science Asia for Mixed Science.
Okay, and Vietnam, as like most of the Asian countries, is a great user of antibiotics. Mm-hmm. And could you give us more insight about their regular use of antibiotics, either as therapeutics or AGPs in Vietnam?
Yeah. Yes, Vietnam is a very big consumer of antibiotics. Vietnam uses around 1,000 tons of antibiotics per year. So you know, the wide use are, I would say, antibiotics are abusively used by farmers' habit. Whenever their animals have health problems, the farmer diagnoses the animal by the eye, and they treat the problems with all kinds of antibiotics. The doses and times are not respected, so making the treatment less effective. Yeah.
Okay, and you mentioned that the ministry, the MRD, is willing to get rid of the AGPs in Vietnam. And what is exactly the situation regarding that withdrawal of AGPs in Vietnam?
Yeah. MARD is Ministry of Agriculture and Rural Development, Vietnam. Okay. Yes, Vietnam, recently has signed a law to lower the level of antibiotics and limited only 15 antibiotics AGPs in feed. So they aims moving out of AGPs by the end of 2017. And thanks to this situation, I see the farmers are looking for alternatives, okay. Like a probiotic, organic acid, enzymes, herbs. But I see the most popular candidates for alternatives actually on the market are probiotics and herbs. Okay. But there is no single solution. I see some performance farms start on association between different techniques in husbandry and biosecurity measures, water management, and nutrition balance. So in this case, when the measures are well done, the alternatives, the use of alternatives is more effective. Mm-hmm. Yeah.
So education of the farmer will be a key point to get rid of this antibiotic usage.
Yeah, exactly.
And do you think really feasible to have this withdrawal of this ban of AGPs by end of 2017? And what is really the way to go away from the antibiotic in Vietnam for the near future?
Yes, it's a very good question because I see Vietnam is willing to move away from AGPs in 2017, and they want to eliminate completely antibiotics from 2020. But it's quite a big challenge. As you said before, first we have to change the habit of farmers, and I think the government should control the use, the manufacturing, and the consumption of antibiotics on the market. Mm-hmm. Because everyone can buy antibiotics everywhere, very easy. So it's a big problem. I think it's feasible, but it needs more time and a very clear roadmap too.
Okay.
Yeah.
Okay, thank you, Dr. Tivanchon. It's very nice to have this view from an Asian country like Vietnam.
Yeah,
thank you very much.
Thank you.
During the second conference on alternatives to antibiotics, we had the opportunity to interview different participants from industry, academia, or professional organizations. When Europe decided to ban the AGPs 10 years ago, they maintained coccidiostats. But today, in USA, for instance, the no antibiotic ever strategy means that they clear all usage of antibiotic in the whole production chain. This is a further step in reducing antimicrobial usage. The objective of OIE with the partners WHO, FAO is to reduce antimicrobial resistance and develop or recommend a prudent use of antimicrobials. The conference reviews the potential solutions available today and under development for the future to reduce the usage of antimicrobials in animal production. I think worthwhile to clear some issues and risks regarding the antimicrobial resistance. To introduce our discussion today with Professor Philippe Van Immersel and Professor Theo Nieuwold, and thus the first question could be, why do we need to reduce the antibiotic use? Professor Philippe Van Immersel.
Okay, so well, I think that's a clear question with clear answer. Antimicrobial usage should be diminished or decreased, at least, because you really create a pool of antimicrobial resistant genes that is being present in the gut and also being spread into the environment. And the consequence of that will be at the end that a lot more bacterial infections will be not possible anymore to be treated, both in animals and in humans. So it's not really antibiotic residues on itself, but it's really the resistance that will increase and that needs to be controlled. So that's why it should be, well, the use of antibiotics should be decreased, really.
That's a big concern, and I think it's quite a good clarification on the topic. When addressing gut health, Philippe, you mentioned the microbial ecosystem as a key mediator. Can you explain a little bit more the relationship between the feed, the indigestible fraction, and the bacteria?
Yes, sure. In fact, when feed is taken up by the animal, there are a lot of things that happen. I mean, the gastrointestinal tract is quite long, and first, of course, it's stored in the crop of the animal. I'm talking about chickens, of course, by broiler chickens, which already have some minor fermentation by lactic acid producers. Then it's going further in the intestine. And at the end, at a certain moment, it comes, of course, in the small intestine, and this is really the place where the feed is digested by host enzymes, and also where nutrients are taken up by the animal. So that's where the digestion takes place. Of course, you also have many, let's say, non-digestible components that go further in the GI tract and then end up in the distal tract, and this is specifically in the ceca of chickens, where this is being fermented by anaerobic bacteria with production of acids, for example, short-chain fatty acids, well known to everyone. Now, it is important, I think, to note that there are quite a lot of, if you talk about intestinal problems or syndromes in broiler chickens, that this always takes place in the small intestine, problems with inflammation, with the dysbiosis, or even worse, with clinical infections, for example, caused by Clostridium perfringens and necrotic enteritis. It's always happening in the small intestine, which is the place where digestion takes place, so that's very crucial for the animal performance, of course. Now, the interesting point is that what happens in the distal gut, in the ceca, so this fermentation of non-digestible substrates there by the bacteria, that really has a very clear effect on the small intestinal permeability, small intestinal inflammation, and even small intestinal repair of lesions. So that's, I think, very, very crucial there. So that, of course, also means that we can really, well, steer a bit the problems that arise in the small intestinal tract by delivering non-digestible substrates to the bacteria that occur in the ceca. And what happens there, for example, is production of acids, and butyrate is a very important one that has these effects on the small intestine, for example, also when it is produced in the hindgut.
Okay, so Philippe, when you talk about microbiota and what is a good or a bad microbiota, it's often a question we have, from the field.
Yeah, it's many people will give probably a very complex reply to that, because if you look at the bacterial diversity in the gut of humans or animals, it's very, very complex. You have thousands of different species, but I think you can probably really differentiate rather easily between beneficial and harmful microbes. And therefore, I mean, if you look at the gut, you have, depending on the site where you are, so small intestine, duodenum, ileum, ileum, or even the distal intestinal tract ceca, you have quite some variability. In the ceca, for example, you have a huge number of different bacteria, which really exceeds even the number of cells that are in the body of the animal, of eukaryotic cells. So it's a huge amount, a huge diversity also. But I think a very important component of the microbiota is really located very densely or closely to the epithelial cells, and this is these are called the mucosa-associated bacteria. They are very closely interacting with epithelial cells, and they are delivering signals to the host. And if you look at which bacteria are present at that specific locations, so in the mucus very close to the epithelial cells, often in cases of disease, these are opportunistic pathogens. Clostridium perfringens is the most well-known. This is a bacterium that produces toxins and is causing, for example, necrotic enteritis, either in clinical or subclinical form, but also a lot of members of the family of the Enterobacteriaceae, and these are, for example, Escherichia coli and other potential opportunistic pathogens. On the other end, what you also have there very closely interacting with epithelial cells are, for example, butyrate-producing strictly anaerobic bacteria. And butyrate is a beneficial molecule. So that means that the balance between these beneficial microbes, the butyrate producers, and the other ones really determines quite a lot on what is happening in terms of gastrointestinal health in any animal species. So this balance is very important. We should keep up the beneficial ones, butyrate producers, very high there, and the other ones we should keep as low as possible.
So you really talk about ecosystem and microbial ecosystem. So feeding the microbial ecosystem, how is the relationship between the substrate, nutrient substrate, polysaccharide, proteins, and the bacteria?
That's a very interesting question, because you can really steer the microbiota composition to a certain level, especially in animals that are not really performing well or having some intestinal problems, which means that they have some kind of a unfavorable microbiota shift, which you can really resolve by providing substrates. So generally, if you're just talking about what happens with feed, you have, of course, the sugars, the proteins, and the fat. With the sugars, they are, in fact, the end products of bacterial fermentation of polysaccharides are short-chain fatty acids merely. And what really happens is that these polysaccharides, for example, pectins or ranabinoxylans, even cellulose or other components, they are degraded by certain groups of bacteria to produce short-chain oligosaccharides, shorter oligosaccharides, for example, arabinoxylan oligosaccharides. And on their turn, these are used by other bacterial species to produce, for example, short-chain fatty acids, acetic, propionic, butyrate also. So this is important, and this is a phenomenon that is called cross-feeding. So different microbial populations break down a certain substrate, and these end products are given to another bacterial population which consumes these products further to a certain end product. And that means that there's a network of bacteria present in the gut that really feed each other. That's quite an interesting concept. Also, there are quite a lot of lactate producers, lactic acid producers in the gut, and this is also some molecule that is in fact on itself not really beneficial, because in fact it's a toxic compound, but when it is used by other bacteria to produce, for example, butyrate, then it's also becoming beneficial. So that's also some typical example of a cross-feeding network. You also have always gas production during fermentation, which is mainly also hydrogen, carbon dioxide that are produced. And again, here, this hydrogen can be consumed by different types of other bacteria. And also there you can have bacteria that, for example, use it and produce, let's say, acetate, for example. These are called the hydrogenotrophic acetogenic bacteria. But other bacteria on their turn can use this hydrogen to produce, for example, hydrogen sulfide, which is, again, potentially a toxic compound. So there's some kind of a balance between, you need a good balance between these bacterial species that really convert these different substrates to, beneficial or harmful end products. So we want metabolites that are beneficial, such as butyrate, maybe other acids, and we do not want these metabolites that are potentially toxic. The same can be said about protein degradation, although in contrast to sugar fermentation, there's not too much known about degradation end products, bacterial end degradation than of proteins. Looking further into, for example, these proteins. In fact, it depends really on the, well, let's say the protein source or the composition of proteins, what the end products will be at the end. But typical end products of protein degradation by bacteria are also short-chain fatty acids, but also branched-chain fatty acids, and also many different amines, polyamines, which are compounds of which some of them at least are believed to be harmful for the host. So normally you should expect that these proteins are really taken up early in the small intestine, but when this is not the case and this is used by bacteria, often this is considered to be not favorable. But this is really something that is depending on the type of end products that are produced. Another example are these, for example, aromatic amino acids that can be converted to compounds such as indoles, phenoxyacetate. So these products are also considered to be, at least some of them, to be not really beneficial or even harmful for host cells. And then again, you also have sulfur-containing amino acids, methionine, cysteine. If bacteria use these, they produce again hydrogen sulfide, which is at a certain concentration also believed to be toxic. So again, there you have this balance between bacteria that use some kind of compounds to produce, well, more or less beneficial products or harmful products, so you need to balance it. That's the theory behind what bacteria do with proteins and sugars, which is in general, sugar fermentation can lead to potential metabolites, of which butyrate is the most important beneficial one.
Thank you, Philippe. So if we understand well, in fact, the job of the nutritionist is even more complex. We have not only to feed the animal, but also to feed the microbiota. Professor Nieuwold, Theo, you seem to focus more on inflammation regarding gut health. Could you precise what you mean by that and what are your observations?
My observations in terms of the antimicrobial growth promoters, how they exactly work, I believe that the basis is that they are anti-inflammatory agents. In the first place, inflammation is the most important part of the inhibition of growth. For instance, or the main two ways it works is that it will catabolize muscle and at the same time also cause inappetite, so a depression of food intake. How do we know that? We know that when we look at the relationship between the type of antibiotic and whether or not they have a direct anti-inflammatory effect. As I've indicated in slide 2, there is a perfect relationship. So that means that indeed we have a strong indication that the actual mechanism of at least those antibiotics, those types of antibiotics, work through the inhibition of inflammation. If we then look at how they are used, in the first place they were used as the so-called AGP, anti-inflammatory, antimicrobial growth promoters. There the anti-inflammatory effect is the main effect. And since they have been outlawed, people switch to the use of the same antibiotics in therapeutic dosage, and then they still work also in an inflammatory way. But then you could call it a side effect, but a very welcome side effect. In any case, most important point is both are growth promoting, and they have a strong effect on small intestinal inflammatory cells, and as we know since very recently also on enterocytes.
So Theo, you mentioned that anti-inflammation properties could help to define alternatives to antibiotics. Can you illustrate a little bit more on that potential?
I certainly can. So the main point I was trying to make is that the positive properties of certain antibiotics are based on anti-inflammatory properties rather than their antimicrobial properties. So that means that, in my view, alternatives to those AGP, the antimicrobial growth promoters, should have anti-inflammatory properties. So what we do, our approach is we do a simple pre-selection in vitro using an inflammatory assay. It's essentially macrophages in cell culture, and we induce inflammation using an inflammatory agent, and then add those compounds, and in that way we can easily determine whether we have a promising compound or not. We have selected a lot of different compounds as yet, and for instance, this what probably everybody knows, fatty acid butyrate is one of those compounds. It works very nicely indeed. And then we also tested herbal compounds, and I just want to use it as an example amongst many others. And that's what is in my slides about plume poppy extract. So it appeared to be from the in vitro assay a very promising compound. So we went on to test it in vivo in broilers, using as a positive control oxytetracycline as a very effective growth promoter, and of course untreated ones, and then 3 different concentrations of the plume poppy extract. And as you can see, concerning technical parameters such as growth, feed conversion, we saw a very nice dose-dependent growth promoting effect. And we also checked whether it was indeed based on an anti-inflammatory action. For that, we looked at the expression of INOS, which is short for inducible NO synthase, which is a gene which is a very important inflammatory cascade in the small intestine. So that shows very nicely that we have indeed growth promotion by inhibition of inflammation. We've also tested it using, for instance, proteomics, and we see essentially the same picture. Then what was very important to me is that this we always have to look at intestinal markers. In this way, it is very cumbersome and very difficult and slow. So what we were looking for were simple biomarkers, which were preferably non-invasive, and of course, fecal biomarkers are just utterly non-invasive. And so what I knew from my cooperation with human medicine here in Leuven, what's used there, for instance, in humans, indeed, it's myeloperoxidase in the disease of Crohn, and it has a very nice correlation with the inflammation in the small. We've tested it in pigs, and in pigs it works perfectly. It's the same as with humans. The problem with broilers is they are, or chickens in general, that they are very different from animals. So they don't even have myeloperoxidase. From the literature, we know that there is one suggestive alternative, which was neopterin, which is the derivative of a nucleic acid. We have tested it, and our most recent results show that indeed neopterin works as a marker of small intestinal inflammation in chicken, and it correlates also with growth and health. And we hope to be able to publish that pretty soon.
Thanks, Theo. I would like to ask the last question, maybe to summarize what you mean by gut health in maybe one slide.
Yes, there's several ways to define gut health, but I think the most practical one is that gut health means that there are very low fecal indicators of inflammation. There's inflammation in the small intestine, especially, that is very central to gut health overall. I believe that what is usually underestimated is the role of just the host itself. I know that there's a lot of talk about the role of the microbiota. I'm more inclined to put the emphasis on the importance of the role of the host, meaning there's the whole immunology of the host in the whole interrelationship between the host and the microbiota. And I think I take that as a major argument that we can easily indeed see very nice relationship between inflammatory compounds in the feces and growth and health.
Philippe, can I ask you also to summarize what you mean by gut health and how to develop efficient alternative solutions?
Okay. Well, gut health is, I think, quite a complex thing to define, really. I think there are different possibilities. Of course, you can look at it at a macroscopical level, just look at the gut wall, and then if you don't see overt lesions or anything, any difference between the normal condition, then I think you can, well, more or less define it as it's good gut health macroscopically. Of course, that doesn't mean that there's nothing potentially wrong. So anyway, you also have some kind of a microscopical definition. I think what would say that you have, if you look at the gut wall, you have optimal villus length, no inflammatory cells, or at least a low abundant number of inflammatory cells available, so no inflammation, and a normal villi structure that would be, of course, related to digestion. The absorptive surface is then, of course, high. So that's important, I think. Of course, this is not something you can easily measure, as already said. This is something you can't really use in the field easily. I think there's also something, if you want to define gut health, you can also give a microbiological definition, I think, which would say that you have, if you look at the microbiota composition, bacterial composition, you have a high diversity, so that this network of functions can be present to digest a product or a substrate to an end product, such as butyrate or acetate. Okay, but also the microbiota composition should be as such that you have quite a high amount of anti-inflammatory bacteria, which are typically butyrate producers, and these are causing, when an animal has inflammation, these cause really dampening of these inflammatory effects. And of course, you don't want all these, well, opportunistic pathogens expanding in colonization of the gut. So you want as low as possible numbers of Enterobacteriaceae, Clostridium perfringens-like organisms, so that you don't have a lot of potential toxic bacteria being present that contain a lot of LPS, but also produce a lot of toxins. So this balance. So I think you can have different definitions of gut health, but this microbiological definition is also a good one, I think. And of course, it's well, it's not so easy to really define. It depends on many different conditions.
Okay, thank you, Philippe. Maybe it's time to let the floor to our participants and to the questions we receive through internet. So maybe we can start with the first question. It's maybe quite a general question, but what are, in the usage of AGP, what are AGP benefits? What are the issues of their withdrawals? I may ask maybe to Theo first to answer to that question. I hope that the connection with Leuven is still working. Theo, can you answer to that question?
I think it's pretty clear what their benefits were. That they just promoted growth and health. And also what it did was to keep the pathogens down. So what we see is, what is one of the issues of the withdrawal is that we see indeed certain pathogens which benefit from inflammation in the intestine, like for instance Clostridia. They are on the rise, and that is not a coincidence. So it's rather important that we still use certain compounds which are able to dampen inflammation, to also contain those pathogens and still benefit growth and health.
So, Philippe, on the same question, the usage of AGP and their benefits and the loss we have with their withdrawal. What is your feeling on that?
Okay, well, the benefits were quite clear. I think they improved animal performance, so which means they improved body weight gain and also improved feed conversion, decreased feed conversion. So it clearly had an economical advantage. So that's, of course, by the actual reason why they worked is not really too clear, I think, but probably at least they suppressed part of the gram-positive flora, so that at least you had less subclinical infections also, which contributes to the economical advantage. Specifically, I'm thinking about Clostridia again, but also you had less interference with nutrient digestion in the small intestinal tract, so that more nutrients were available for the host. In addition, you have, of course, anti-inflammatory effects, maybe also either directly by the AGPs or maybe indirectly by suppressing the microbiota. This is not yet clear. So the effects of withdrawing would be, in principle, again, animal performance becoming a little bit worse, but of course you have quite some additives to restore that. So.
It's quite interesting, in fact, to look at both aspects, the microbiota and the inflammation part. So maybe another question from the web. What are the criteria to take into account to set up an efficient AGP-free strategy? I think it's quite relevant to the previous question, so I will ask Theo, and I hope the Belgian connection is still working, on that first question.
That has, in my opinion, to do with the availability of really efficient alternatives. And that has been, I think, largely the problem with the old theory about the working mechanism of AGP that was based on the antimicrobial strategy. And it wouldn't surprise you that I'd rather say it should be based on the anti-inflammatory theory. So use components which have a proven effect on inflammation. And I think that's the way to go forward, because don't use proven concepts and alternatives, then farmers will still be tempted to go for the old compounds, so to speak.
So, Philippe, your potential answer on the potential criteria we should take into account to set up alternatives.
Yeah. An alternative program, I think there are many, there are different things you have to consider there. First of all, I guess the overall management of the farm is important, meaning that the biosecurity plan is crucial, I guess. I mean, you have to make sure that the animal spends energy in not in combating potential infections. So that's why biosecurity is so important. You have to exclude potential pathogens, keep them out of the flock, of the farm, and also make sure that there's no spread within the farm or between different flocks. So biosecurity is one thing. Secondly, of course, there are quite a lot of possibilities to, let's say, stabilize the gut microbiota or even stabilize the gut barrier, at least, with a lot of different feed additives that are available on the market, of which some are quite helpful, I guess, in really making sure that the bacteria that are present in the gut are really these ones that have anti-inflammatory effects and stabilize the gut barrier. So I think there are quite some possibilities to, have an AGP-free flock.
Okay, thank you. Maybe another question from the web, which is relevant to your both presentation, I would say. What biomarkers could we think about to appreciate gut health in broilers? And maybe one even more for Theo. How can we detect gut inflammation in gut broilers?
Yes, as I just said, in my presentation, there is one in broilers, and that's a fecal, or it's not the exact term in broilers, of course, a biomarker in the excreta, and that's neopterin. That is indeed quite a rapid method, meaning you will have the results in one day. Very simple. You could just take droppings from a pen. For instance, if you want to compare two treatments from one department, you pick the droppings in the other one and then compare them. So you will get your values in a day, which will enable you to, for instance, make adjustments in the composition of feed, or just adding anti-inflammatory compounds, etc. So I'm very optimistic.
Philippe, I'm sure that you have maybe a different interpretation from Theo on what potential biomarkers. And I would say I insist on the fact, talking about also practical biomarkers that we can use in the field.
Well, I don't know whether I have a different view on biomarkers than Theo, but I think you have you have quite a lot of potential possibilities for biomarkers for gut health. And basically, when you look at the gut, I mean, the gut barrier is important, so that means that epithelial integrity is important. The epithelial cells need to be very closely connected to each other to avoid that you have toxins or feed compounds leaking into the mucosa and causing inflammation. That's one thing. And secondly, also you have to have a closed epithelial barrier to avoid that all kind of proteins are leaking into the gut, and this would also be an energy loss. So this gut barrier is maybe point one. You can detect some of the proteins that make connections between the epithelial cells, and if you have a lot of gut damage, for example, you can potentially detect these proteins, the tight junction markers, as it's called, in the fecal material. That's one thing. Secondly, of course, you have these inflammation markers, meaning that in cases of severe inflammation in the gut, you have a lot of immune cells that secrete a lot of different compounds, and some of them are some of these immune cells, they are really transmigrating, and they end up in the gut lumen, so and also will end up in the fecal material. And some of these proteins that are inside these immune cells, such as neutrophils, heterophils in chickens, they are also secreted there, and it can be found in the fecal material. That's the second thing. Thirdly, of course, you have potentially also some microbial markers, because if you have an unfavorable microbiota composition in the gut, you would of course also be able to detect that in the fecal material. This can be done by DNA techniques, very simple DNA techniques, just quantifying certain populations or ratios of populations. So in fact, the most crucial thing, I guess, is really to have an easy field test at the end, what would mean that you need some kind of an test on fecal material, ELISA test or something else that is easily detecting these different markers. That's, I think, crucial. We can't have some tests that we take a fecal sample, we submit it to a laboratory, and then have to wait for 2 weeks before we have a reply. It should be something that is very fast, reliable, standardized, and that's what we need to develop, I think. It's not really the case yet, also because many of the tests being developed, for example, for humans, they are not valid in chickens, because chicken
they don't have the same
proteins, they don't have the same protein homologs, for example, so it's a completely different animal. You can apply that to pigs maybe, but not to chickens. So we are still struggling a bit with that, but in the future it will be developed. I'm quite confident.
How far do you think it's possible to have this type of biomarkers ready to use in poultry production and on a quite rapid economic basis, this type of biomarkers? How far from now you think it could be available?
I think, some people are working on it. We are also working on it in our university. I think it would be possible to have these kind of things within the next few years, and really to put a number on it. Maybe something like, 2 to 3 years if we are lucky. And if we are unlucky, something like 5 or 6 years. It depends a bit how lucky we are with detecting potential biomarkers and identifying the good ones. That's always a little bit a risk, I think, because it doesn't only have to work in the laboratory. It should work in the field, of course. That's the most difficult thing. Yeah.
Thank you, Philippe. Maybe another question from the web? Maybe a tricky question. Should we look for more mucin production or less for better gut health? And I'm sure maybe looking at inflammation, we can ask Theo to answer first to that question. Theo?
I'm afraid that I don't have an answer to that. I don't see the direct connection between mucin and gut health. So I'm not the person to answer.
Yeah, good. Maybe Philippe, you can react on that on the mucin aspects. Should we have more or less mucin?
It's a very difficult question. I don't think I know the exact answer. Mucin production is obviously also sometimes increased mucin production is also sometimes a consequence of a certain insult, pathogenic insult. For example, coccidia, they increase mucin production if you have an Emeria infection, coccidiosis, for example, and that is then maybe linked to the fact that if you look at microbiota, some of them can use mucins, can live in the mucus. One of the examples of a pathogenic bacterium that can do that is Clostridium perfringens. It likes to eat mucins, and for example, that's probably the reason why if you have coccidiosis, an increased mucin production, that you have some kind of a predisposing
environment
effect for necrotic enteritis, a predisposing environment for the induction of necrotic enteritis by Clostridium. So that's one thing. Of course, you also have other bacterial species that can consume mucus, and also some of these are quite interesting because some of these produce high quantities of butyric acid. You have some examples, Akkermansia is one of them, but these ones are very beneficial because we as a host, or the chicken as a host, provide them with certain substrate, mucins, which enables these bacteria to live very closely in contact with the epithelial cells, and they provide us with butyrate, which is a very anti-inflammatory molecule, which strengthens the epithelial barrier, etc., so which has very positive effects. So it depends a bit on the situation. I think it depends which microbiota is present in the gut, but in fact, if you think about it, it's a very, very interesting system in which we as a host give some kind of a feed to some bacteria that we need for an optimal gut health. I think it's amazingly interesting to consider that.
Yeah, more and more complex for the nutritionist always, I think. Maybe a last question from the web. What about lameness? Can gut health promoting compounds to be used to control emerging disease? I'm sure that when we talk about lameness, it's more what we heard yesterday about in the conference about the translocation of bacteria from the intestinal area to the rest of the body, in respiratory tract, in joints and so on. And people are concerned more and more now on how gut health can improve or reduce this type of translocation of bacteria.
Yeah.
A comment maybe directly from Philippe.
That's a good point, I think, because this is in fact an emerging problem in the broiler industry, lameness. And if you look at these conditions, then if you look at, well, for example, one of the conditions is bacterial chondronecrosis with osteomyelitis. You also have spondylitis, so different problems with bacteria that translocate from the gut to the bloodstream, and then for some reason attach or colonize specific places in the body, such as the joints. These bacteria, if you isolate them from these specific places, they are E. coli or Enterococci, and these Enterococcus species, they are typically Enterococcus secorum, which is one of the bacteria you very often find there. But these bacteria, they are just gut inhabitants. So that means that they originate from the gut, and probably this gut permeability or this epithelial barrier strength is really key also in this kind of disorder. So when you don't have an properly functioning gut, and when you don't have a good epithelial resistance, when you have high permeability, this can also translocate and end up at these specific locations, which means that, for example, with interfering in the gut with probiotics or other compounds that stabilize the gut barrier or modify the gut microbiota composition to a favorable one, that you can also control diseases outside of the gut. That's also fairly interesting that bacterial signals, in fact, that you can steer with feed or feed additives can be altered so that certain syndromes or conditions or diseases outside of the gut can be controlled. That's also a fairly interesting concept.
So it's interesting to see how gut health can influence, in fact, the global health of the animal. So we should not separate the things, I would say, and really consider the health as a global issue for the animal productions. So I think we have much more questions, but we will let maybe the answer coming on the web after. And you will receive questions that we could not answer this afternoon, Philippe and Theo, and hope you will be able to answer to our participants. So to conclude, I would like to warmly thank our today's speakers. speakers, so Theo from Belgium and Philippe from Paris, I would say, and also Dr. Thibanchot and all participants we interviewed during the second ATA conference, who accepted to share their experience, but also for your participation with the questions and so on. We also thank ATA to give us the opportunity to interview people during the conference, and also the OIE organizer and the general director that we are going to have as an interview also on the FeedChannel site. You will be able to watch again the program and from the interview to the debate, and also to put more questions on feedchannel.online. I hope you enjoy this second webinar on gut health, and I would say let's be addicted to our FeedChannel series, and I give you a rendezvous for the next webinar in February, hopefully on the 22nd of February. We will continue to focus on gut, but maybe to be away from Philippe and so on, we'll try to focus more on the digestibility, on the condition within the digestive tract. But I would say now, as a nutritionist, we need to really look at the global issue. But it's quite interesting. So you will receive notification in due time. And before to say bye-bye to everyone, I should not stop here in December before closing the seminar without wishing all of you Merry Christmas and Happy New Year, and hope to see you all in 2017.